Hello everyone. This is in continuation to our topic analytical geometry. We already had seen about angle between two lines. Further, we will note this one. If two lines are parallel, then their slopes will be equal. And if two lines are perpendicular, then the product of their slopes will give you -1. Means let line L1 has a slope M1 and line L2 has a slope M2. If L1 and L2 are parallel, then M1 is equal to M2. If L1 and L2 are perpendicular, then M1 multiplied by M2 will be -1 or M2 will be -1 by M1. Now let us do some problems in this related to angles and slopes. Find the angle between the straight line 3x minus 2y plus 9 equal to 0 and 2x plus y minus 9 equal to 0. Consider this as equation 1, this as equation 2. Now we can rewrite the equation 1 as -2y is equal to minus 3x minus 9. Further, dividing both sides by -2, we will have y is equal to minus 3x by -2 minus 9 by -2, which is y is equal to 3 by 2 times x plus 9 by 2. Comparing this with y is equal to m1x plus c1, we have m1 is 3 by 2 and c1 is 9 by 2. Now, same way, let us consider second equation. We can rewrite it as y is equal to minus 2x plus 9, which means comparing this with, let me rewrite this, comparing this with the general form, which is y is equal to, let me consider it as m2x plus c2. We have m2 is equal to minus 2 and c2 is equal to 9. Now, angle between these two lines is tan theta. That will be modulus of m1 minus m2 divided by 1 plus m1 m2. So that will be m1 is 3 by 2 minus m2 is -2 divided by 1 plus 3 by 2 multiplied by -2 under modulus. That becomes 3 by 2 plus 2 divided by 1 plus, here it becomes minus now because of that -2 in that, 1 minus 3 it will become. So calculating this, we will have LCM is 2, 3 plus 4 divided by -2. So we will have modulus of 7 by -4 and will come 7 by 4 modulus, which means our angle theta will be tan inverse of 7 by 4. That is the solution for this question. Let us move on to the next one. Show that the straight lines 2x plus y minus 9 equal to 0 and 2x plus y minus 10 equal to 0 are parallel. So consider this as equation 1, this as equation 2. 1 can be rewritten as y is equal to minus 2x plus 9. Second equation can be rewritten as y equal to minus 2x plus 10. So this implies that our slope for the first line, we will call it as m1, is minus 2. Slope for the second line, we'll call it as m2, that is negative 2. Since m1 is equal to m2, line 1 and line 2 are parallel. That is the proof for that. Let us move on to the next one. Show that the straight lines whose equations are x plus 2y plus 5 equal to 0, 2x plus 4y minus 5 equal to 0 are parallel. Again, equation 1 can be rewritten as let us as it is write it. Equation 2 can be rewritten as dividing both sides by 2, we will have x plus 4 by 2 becomes 2y minus 5 by 2 equal to 0 by 2 is 0. Now we can say since coefficients of x and y are the same and only constants differ. Constants means here it is 5 and minus 5 by 2. Constants differ. Hence, these two lines are parallel. That is the solution for this particular question. This is another way of solving it. Or we can write it like y is equal to mx plus c form. Identify what are the slopes. If the slopes are equal, we can say they are parallel. Same way also you can do it. Next question, question 31. Show that the straight lines 2x plus 3y minus 9 equal to 0 and 3x minus 2y plus 10 equal to 0. Consider this as equation 1 and equation 2 or at right angles. Means we will identify the slopes first. In the first one, we can rewrite it as 3y is equal to minus 2x plus 9, which can be rewritten as y is equal to minus 2 by 3 times x plus 9 by 3 is nothing but 3. So this implies that the slope for the first line, m1, will be negative 2 by 3 and the y-intercept will be 3 for the first line. Second equation can be rewritten as negative 2y is equal to minus 3x minus 10. Dividing both sides by negative 2, we will have y is equal to minus 3x by minus 2 minus 10 by minus 2 means y is equal to 3 by 2 times x plus 5. So from this, we can say the second line's slope, which we will call it as m2, is 3 by 2 and the y-intercept for that is 5. Now, m1 multiplied by m2 is negative 2 by 3 multiplied by 3 by 2. We will get minus 1. This implies that line 1 and line 2 are perpendicular to each other. Means line 1 and line 2 are at right angles. That is the solution for this question.